everyone, welcome back. In the last few videos I focused on activities that help students explain how visuals show information. But students also need perceptual intuitions. These intuitions are at play when we follow visual cues without thinking, like when we stop on red or when we just kind of know whether a pie chart shows a big or a small proportion without counting pieces or even measuring area. And this intuitive knowledge about visuals comes through experience with many examples that we accumulate throughout our lifetime. Intuitive knowledge about visuals is often called visual fluency because experts can navigate the multitude of visuals that are out there in their fields as if they were fluent in a visual language. And this intuitive knowledge is also involved when we translate between visuals. A chemist, for example, sees much more in this ball and stick model of water than a red sphere and two white spheres. The chemist would normally see information that is shown in a different visual, say a Lewis structure that shows that an oxygen atom has two lone electron pairs, and they might also see that this actually explains a lot about the properties of water, including why ice is lighter than water, and why it takes so much energy to heat water up, and why there is surface tension. So this intuitive knowledge about how different types of visuals relate to one another allows chemists to do a lot of complex thinking because they don't have to laboriously translate the ball and stick model into the Lewis structure by saying, well, red stands for oxygen, and I know that oxygen has 6 valence electrons, and white stands for hydrogen, and so forth. So these perceptual intuitions are important for learning because they give students the headroom to do more complex thinking. I'm going to give you another example. We recently had a solar eclipse here in the United States. How many of you were puzzled that the eclipse actually moved from west to east? Because we're all so used to the sun and the moon rising in the east and then setting in the west. So we have experience-based intuitions that in this case are wrong. I had to watch this NASA animation to make sense of this, and I highly recommend it if you're interested. Essentially it's because the moon's shadow on the earth is moving from west to east. So this is an example where perceptual intuitions actually get in the way of complex thinking. And that also illustrates why it is so important to make sure that when you're teaching, you're creating helpful perceptual intuitions. How do we do that? Well, first we ask ourselves, what are the visual features that we want students to learn to become attuned to? For example, for fractions, it's important how large of a proportion is colored. That determines the magnitude of the fraction. And then we want to create many examples where this visual feature, say proportion colored, is important. And then vary all other features like the size of the circle or the color. And then we want to create a task where students have to attend to the important feature while disregarding the unimportant features. For example, we could ask students to judge which proportion is larger and give students many of these examples. But yeah, there are many ways to train students' intuition in this way without using technologies. You can use card games or sorting tasks, or you can just make sure that you use different examples throughout your curriculum that vary the irrelevant features and focus attention on the relevant features. But yeah, my research is about educational technology, so as you might have guessed, in the next video I will show you how to create technology-based activities that do this, that train students' intuitions about visuals. And these are actually a lot easier to create than the other types of activities that I've shown you in the past videos. So I hope you will join me again next time.